Good morning everyone. Myself Ritu Singh, Assistant Professor in Civil Engineering Department in Lakshmi Institute of Technology, Saregam. Today I am going to take the first lecture of concrete technology that depends on the history, development and future trends, whatever in all like conclusion of concrete. What is concrete? So the contents here we have in the lecture is introduction, what is concrete and all, history behind the concretes, from where it comes, then what's the advantage of concrete and what's the future trends is going on in concrete. So concrete is a very strong, as we all know that concrete is a very strong and versatile multi-level construction materials. What it consists? It consists of cement, sand, aggregate, and this all mixed with water. So we all know that the cement and water form a paste or gel which coats the sand or aggregate or any other things we are using. That cement and water, on the gel with water it form a gel and it coats the sand and aggregate. So when the cement has chemical reacted with the water, it hardens and binds the whole mix together. So the initial hardening that took place is usually occur in few hours. Like we all further we will learn that the initial setting time of the concrete or cement, final setting time, and how much it take longs to gain like strength like stone. So it takes some week for concrete, like we are having given in the IS code we are given the 28 days we have to check for the full strength of concrete, whatever the grade we are using. This we will further will learn. Now what is the history behind this concrete? So we will talk like 127 AD, the Roman concrete. So what Romans have made this Romans used concrete to construct wall and roofs. Only they have prepared the wall with the help of concrete, and not concrete, but they have used the they have used the lime and mixed with other materials, and they looks like concrete. So these forms were used with the stone and mortars being placed in alternating layers. So what's a mortar? First we will talk. Mortar is the mixture of cement and water. So this plastering we are doing. So this is a mortar is a mixture of cement, sand and water. So this becomes one mortar, and this also forms a binding. So this finished concrete, whatever the mortar they are preparing, they are using with bricks or tiles as a flooring or in the walls they are preparing. So from the Romans, after the Romans, they have used this formula had been not lost while the Romans empires they have lost, but others also followed this formula, and this is followed by Northampton. So they are starting using this concrete as in horizontal beam, and this rotated on the central shaft. So you must be knowing what is shaft. Central shaft means like nowadays we are using the pillars or the connecting the two structure with the pipes. So you can prefer the column as a shaft. Now this Normans had knowledge of concrete, and like the Romans used it for the wall infill. So this Romans earlier I have said that they are having the knowledge of concrete, and they started using it as in fill, like they are starting using a column fill or wall fill, and they found that pounded tiles or bricks mixed in with a lime mortar and sand produce a similar reaction to that of the Roman pozzolana. So the crushed tiles and the brick provided the needed silica and alumina. So this as we are knowing that cement is made of silica, alumina, iron oxide, these all materials. So when they are crushing these tiles on bricks, they are finding this silica and alumina. So the use of this hydraulic setting pozzolanic concrete in the construction of 240-kilometer long canal they have made, and this in France Mediterranean coast they have prepared in these years. So world transforming materials. So concrete in the history also the concrete becomes world transforming materials. So it could be justifiably argued that since the late 1800 onwards, when consistent mass produced Portland cement became readily available, that the world that we live in has been transformed by the design and construction of all sorts of concrete structure. So you must here now also we are having PPC, OPC, that is Portland cement we are having, that's brand have become. So in the history also, in the history only this brand have become, that is Portland cement. Now we are not using that cement, but the brand still remain as it is, as we are not for the photocopy we are not using Xerox machine, but still we are using that word Xerox. So here is the advantage of the concrete. What is the advantage of it? Why they have started using the concrete? So ingredients of concrete are easily available in the most of the places. Ingredients, what is the ingredients of the concrete? Cement, sand, aggregate, these all are the ingredients of the concrete. So it's mostly available in all the places of the world. Unlike natural stone, concrete is free from defects and flaws. Natural stone, you can see the natural stone, igneous rock, sedimentary rock and all the rocks, these all are free from defects and flaws. Like this, concrete is also free from the defects and flaws. Concrete can be manufactured to desired strength with economy. So concrete it is manufactured with desired strength and economy. Desired strength and economy means if you want to prepare a good durable buildings, so we are preparing the concrete of M20, M25 grade, M30 grade. So according to our desire, according to our economy, so M20 we also can make of M20 grade and it will be durable instead of M30. So we can prefer our we can do with the desirable and with the fund available, we can use the grades of concrete, and so it is with desired strength we can gain and with economy we can handle. Then durability of concrete is very high. The durability of concrete, durability means long time. So durability 100 years it is designed of every concrete, every grade of concrete we are using. Then it can be cast to any desired shape. Of course, we can cast to any desired shape, any design of the building can be manufactured by, can be developed with the help of the concrete. Casting of concrete can be done in working site, which makes it economical. So casting we are doing, casting means like slab we are casting, column we are casting, beam we are casting. So at that side itself we can cast, so we can avoid the deterioration of the cement. So the deterioration of concrete is not appreciable with age. So concrete make a building fire safe due to its non-combustible nature. It's a fire safe also. So it is non-combustible. Concrete can withstand high temperature. It can withstand high temperature. It can go with high temperature. So we can manufacture. We can develop the buildings with the help of the concrete. Then concrete is resistant to wind and water. It's also resistant to wind and water, and it's very useful in storm shelters. So as a soundproofing material, cinders concrete could be used. So due to all these benefits, we have preferred the concrete to be used all over the world, and globally we are using this. Future trends in concrete. What's the future trends? What do you understand by future trends? Future trends means day by day we are losing, we don't have enough amount of sand, natural sand We don't have enough amount of cement we are using, that is natural resources we are using in the cement is lime. So we are trying to having new experiments, we are trying to have future trends in concrete. So the concrete can be have a large variety of cement replacement material, and chemical admixtures are already in use. This chemical admixture we are using, this we will further talk in details in further chapters. Concrete can be self-consolidating or roller compacted, have a strength of more than 200 megapascal, and to pumped in 600 meter height, and can claim are made of 100 years of durability. So durability means it can resist 100 of years without any defects, maintenance can be done. Then 6 meter heights it can be pumped out, like high-rise buildings, Burj Khalifa is made of concrete only, but high performance concrete. And self-consolidating or roller compacted. Self-consolidating means if we don't have in normal houses, we don't have machinery of vibrating or compacting, this is self-consolidating. Self-consolidating means it is removing the water itself, it is evaporating or curing itself. Several organizations are investigating concrete made of no Portland, cement, whatever. So mixed design shifting from grading curves to nanotechnology, and natural sand is become unavailable in many areas. That's why these all are the reason for the future trends in concrete. These all are the going on for the future trends of the concrete. One current producer have said that it is easy to make geopolymer. Geopolymer is coming in trends for the replacement of the concrete. So and almost anyone can do it. So however, to make a large quantity of GPC, that is geopolymer, with acceptable properties at a competitive price, at a very different matter. So certainly potentially cost competitive GPC is possible. Indeed, is already in limited production. So however, such GPC need to be reached, full industrial processes should be done. So if we cannot rely solely on GPC, that is geopolymer, what we can replace cement with? Now concrete is made of 50-60% of the part of the concrete is cement. So we first think of cement. So which part we can replace cement by? Fly ash, you can easily get by thermal plant, slag, then silica fume, metakaolin, rice hull ash, and superfine calcium carbonate. These all materials we can replace cement with all these materials by a certain proportion. Now the main topic we start is what is concrete. What is concrete? Earlier I have also said that the concrete is a essential material used in the construction of different type of structure, like whatever you have to make, residential building, stadiums, skyscrapers, irrigation work include canals, aqueducts and all this. Then large offices, airport, trams, then commercial complexes, payments, making bridges, countless prefabricated highways, products, etc. So everything include a structure we can made of concrete. What is the composition of the concrete? This all we are cement, water, aggregate. It must be fine aggregate and coarse aggregate as well, and chemical admixture or mineral admixture. Cement. So what is cement? Earlier in the history also I have said that Portland cement we are using as a brand. In the Roman Empire only they have prepared the Portland cement. So Portland cement is the most common type of cement in general use. It is a basic ingredients of concrete, mortar and many plasters. Water, what is the water percentage we are using, or what is the water role in the preparing of concrete? So combining water with the cementitious material forms a cement paste by the process of hydration. So when you mix water into the cement, it produces hydration, and while this hydration happens, a bond is creating. The cement paste glues the aggregate together, fill voids within it and makes it flow more. Flow more means walkable. So aggregate, fine and coarse aggregate makes up the bulk of a concrete mixture. Sand, natural gravel and crushed stones are used mainly for this purpose. So, whatever the voids they are in the concrete, it's a filled by aggregate. It must be fine or coarse aggregate. So, you can see in the picture fine aggregate and coarse aggregate. Demerits of normal concrete. Now, we have seen from last few slides that merits and advantage of concrete. Now, we must go for the other side, that is demerits of normal concrete. So, compared to other binding materials, the tensile strength of concrete is relatively low. Like tensile strength means opposite. If you pull the concrete, it will break. So, it is low tensile strength. Instead, compressive strength is good. Concrete is less ductile. Concrete is less ductile. Ductile means if you elaborate the things like metal, if you elaborate it, it will form a thinner parts, but it will not break. But concrete is less ductile. If you elaborate this, it will break. The setting time of the concrete is very quick. Setting time is very quick. As you use water, it goes on a chemical reaction under hydration and it will produce the bond, and so the setting time is less. Due to this defect, the admixture can be used to enhance the properties. So, these are the defects of the concrete, and due to these defects, we are using some admixtures to enhance these properties, to have less demerits on it. So, advances in concrete technology. Some advances in concrete technology. There have been a number of advances in new concrete technology in past 10 years. That is, we have having fresh concrete, hardened concrete. These are other chapters, individual chapters we are going to learn. High performance concrete. High performance concrete means there are some concrete we have designed in the IS code till M25, M30. But if you are preparing concrete for more than M30, M50, like M100, M75, then these concretes are called high performance concrete. Not here, you will not understand M. What is M? Mix. It is mix. Means the concrete you are forming in a great proportion. So, the latest new concrete technology is high performance concrete, ultra high performance concrete and geopolymer concrete. So, recycled materials contain this concrete is, what's the recycled materials we are using in this concrete is in high performance concrete? It's a fly ash, ground granulative blast furnace, slag, silica fume. This high performance concrete is used in high towers like Burj Khalifa is a world highest tower. So, there if you go to the Google or Wikipedia, you can see that they have prepared that structure with the help of high performance concrete. What is the benefit of it? So, reduction in the uses of cement. So, high performance concrete benefits: reduction in the uses of cement, reduction in the creation of carbon dioxide emission, energy consumption, very cheaper and higher quality. So, this carbon dioxide emission I need to discuss, as we are going now green building, green sustainable, everything sustainable we want, and global climate change is happening nowadays. So, this carbon dioxide, when we are using cement as a normal cement, that is OPC, ordinary Portland cement, if we are using, the contain lime, silica, alumina, iron oxide and manganese. So, this cement production, when we are preparing concrete and we are forming the structure, this having the carbon dioxide emission in the atmosphere. So, due to this carbon dioxide emission, this global warming is occurring and climate change is occurring. So, when we are using this high performance concrete and we are using some percentage, we are adding like fly ash we are using, and others silica fumes we are adding, then we are also decreasing this creation of carbon dioxide emission. Now, as we are having the green concrete, so we are now the trends going on now in the market, everything we want green, and there is a various institute dealing with the green concrete, that is the LEED or Greher. They are dealing with the this green concrete or green building. We can talk. Green building can be made of one of the part is green concrete. Other factors are also included in the green building. So we will talk here about the green concrete. What is green concrete actually? Green concrete is the environmental friendly concrete. Environmental friendly concrete means it will emit less carbon dioxide in the atmosphere. First of all, concrete that uses less energy in its production, it also have less energy in its production and produces less carbon dioxide that normal concrete is called green concrete. Usually the carbon dioxide is present in the cement and the aggregate. So when we are preparing the concrete with the emission of less carbon dioxide in the atmosphere and less consumption of energy, that the concrete can be called as green concrete. So composition of the green concrete is, it's a 40% Portland cement we are using, 25% ultra fine slag we are using, 25% of ultra fine fly ash and 10% of silica fume we are using, and 4% volume fraction of steel fibers we are using. So you can see in the picture also the concrete's many green benefits make it the sustainable choice. What is the merit of green concrete? It saves energy and saves money also. Increase concrete industry use of waste product by 20%. So waste product, company waste product is just a waste. So we are using that waste product and in the manufacture of green concrete. No environment pollution and sustainable development. Green concrete requires less maintenance and repairs. Green concrete having better workability than conventional concrete. Conventional concrete means normal concrete, ordinary Portland cement you can see. So green concrete have a better workability. Better workability means it gives you more time to work like mixing, transporting, placing. This all includes in workability. Good thermal resistant and fire resistant. What's the demerit of it? So every coin has two sides. So here also we have to see the merits as well as demerits. The main limitation of or disadvantage of using green concrete is that the structure which are constructed using green concrete have less life than the structure constructed by the conventional concrete. It might give less life, less durability. The split tensile strength of the green concrete is less than conventional concrete. Sometimes corrosion in the steel bars are also occur if the aggregate used are not free from corrosion leading agent. So these are all demerits of the green concrete. Features of green concrete. The green concrete must have the following characteristics: optimized use of available materials, better performance, enhanced cohesion, workability, reduced shrinkage, durability, better lifetime, reduced carbon footprints, no increase in cost, and LEED India certification. For the green buildings we are getting, this institute are giving certification to the green building. So optimized use of available materials is optimized use of available material. Whatever the materials resources we are having, we are doing the optimum use of it. Better performance than normal concrete. This cohesion, workability is there. Shrinkage is less. Shrinkage means the water from the concrete shrinks and this segregation occurs. Then durability, better lifetime. Means durable, it is durable, reduced carbon footprint, carbon emission, no increase in cost, it is not costly. So material for green concrete, these are all the materials for green concrete we earlier also discussed. Recycled glass aggregate. Instead of manufactured sand for concrete, we are using recycled glass aggregate. Blast furnace slag, fly ash, and this sand, manufactured sand for the concrete. These are all the materials we are using as the fine aggregate for the green concrete. Then suitability of concrete, reduce the dead weight of the concrete. It reduces the dead weight of the concrete. Dead weight means the weight of the structure like column, slab, and all the weight, furniture weight also including the dead weight. And live weight means human beings. We all are live weight. So So good thermal and fire resistant, improved damping resistance of the building, reduction of concrete industry CO2 emission by 30%. So reduce the CO2 emission by 30%, increased concrete industries use of waste product by 20%, no environmental pollution and sustainable development. So green concrete requires less maintenance and repair also. Conclusion, here we comes for the conclusion. Hence cement plays a key role over past 100 years when humans started construction. So cement is the most building materials used by human. Cement has more compression and steel has more tension. So no other materials present which can replace cement. Thank you.